First of all, I'd like to thank everyone for attending, and I'd like to thank everyone at Taconic for graciously volunteering their facility, but also the technical expertise. So, Frank Razzaboni from Park Bioservices. I have been involved with isolators for about 16 years, and most of that time I have been the president and owner of Park Bioservices, and my role there really I see largely as designing isolators and helping people launch projects. So to get started, we're going to talk about the study project and technical design, and we have some different headings: the vendor selection, animal models, food, testing services, shipping and shipping supplies, isolator and ancillary supplies, and I will cover each of those. Now, as far as animal models, the market right now is very limited as far as commercial sources, and Taconic is really the only commercial source of germ-free animals currently in the marketplace. There are other sources, transfers between universities, and then there's the government. There's a government entity down at North Carolina State that has some germ-free models. Major topic and an area that is probably one of the greatest areas of problems in getting germ-free animals is the food. And there are two ways of approaching it. One is autoclave, which just about everyone here would have access to autoclaves. It's definitely a good way of doing it. It's as good as or in some cases better than the irradiated. However, one of the problems comes in is that the folks that, people that need the germ-free animals aren't often the ones that are in control of the autoclave. And I've seen a number of problems out there where you just have to pay the whole way through a germ-free project. It's just more of attention to detail. So part of the thing, and I'll get into it later, is making sure that the people that run the autoclaves know how important it is to achieve the correct cycles. Then, in terms of irradiated diet, it's a great way. It takes a lot of the guesswork out. However, one caveat is the commercially available food is not irradiated at such a level that it's germ-free. If you read the little blurb, this is straight from one of the, from Purina, it says that it's virtually bacteria-free. What does it mean? I mean, it means absolutely nothing. There are spore-forming rods in the diet, and that is enough just to torpedo your whole project. So then why would I even bring it up as an alternative? Well, the alternative is that you can arrange to have the food have an extra dose of irradiation. And the way that is done is, I think in the United States today, there are two major sources, two major irradiators. So you can send the product off and have an additional dose of irradiation. So you have to determine first what the initial dose was, and then it's cumulative, so you can have additional radiation applied, and that will bring it up to a sterility. And it's important to coordinate with the irradiator so that they understand exactly what you're trying to achieve. And there may be also some issues that you can, and I know in the past we've combined food, bedding, and things that we call setups, like paper bags and stuff like that, all in the same lot. One of the irradiators that I've spoken to recently will not allow that. They want the same densities, and they think it's that important that they don't want to mix densities. So.
Do you know the level of irradiation you need to achieve the sterility you're talking about?
It is 45 kilograms, I believe, would be complete sterility.
So if you've already had an irradiated diet that you buy,
correct.
What do you have to irradiate?
So if it's cumulative, so say it was irradiated at 30 kilograms, an additional 15 kilograms would have to be applied. And it's not that precise, but they'll go over that amount. But they'll give you a range and a certificate of what the range was when they irradiated it. So in talking about bedding, again, it's autoclaved or electron beam sterilized is available. In terms of things that I would personally recommend, corncob bedding is, I think, a very poor choice. and unfortunately a lot of people are using it. It's very dusty, it blocks the filters, and there are contaminants. I won't mention any names of any products, but it is known that, it's been studied that there are contaminants that are in the corn cob that would make it, a less desirable choice. So then there's the paper products, and one of the choices, the alpha, which is the small kind of rectangular chips, I would say is a very good choice because it's very low dust. It absorbs all the moisture, does everything you want a bedding to do. But then there's also the extruded product, which is a gray product. It just fluffs up. That fluff gets into the filters again. You're talking an isolator, less than desirable material. So then you get into what my personal choice would be the aspen shavings. Very low dust, starts with a very low bioburden. It comes in a very convenient loaf or brick of material, and it's a very, very handy product to use. The question, and I can't really answer this question, I try to get the information before the seminar, is the commercially available aspen shaving sufficiently irradiated to just use as is? I'm going to guess that it is not, and better to err on that side than the other. But I think at least one of the irradiators will accept that along with the food, so you could get that additional dose of irradiation, although it's mixing the formats going from electron beam from gamma to electron beam, but it still should work. And that's what the vacuum, they're in vacuum. One of the nice things is it comes in a vacuum sealed plastic bag, so very easy to spray or dunk. So very convenient and kind of ready to use.
So you're talking about the aspen?
Well, this is actually, I'm sorry, on the left is the aspen shaving, and on the right lower corner is gamma radiated food.
Yeah, you can get that from the vendor.
From the vendors, yeah, in that package, yeah. You actually even see it in pet stores, although the pet store product is not irradiated, but it's, yeah.
You wouldn't happen to know if those prepackaged, which are irradiated, are also, the plastic is autoclavable?
Is it autoclavable?
I could just throw a package of that as is into an autoclave.
I don't think so. I don't think so. Yeah, it's made just to be used, taken from that state and dunked or sprayed. Yeah.
For example, they didn't want to trust the irradiation, they wanted to actually
Autoclave it as well?
Autoclavable in that form or not?
I don't think so. Yeah. So water, some very basic options. You have on the extreme left, you have the water bottle. That's a 4-liter. It's a little fuzzy, the picture, but a 4-liter bottle. That is the way a lot of people autoclave their water. One reason I don't like it is that it's very heavy and kind of cumbersome to manipulate inside an isolator. It's my own personal preference. There's the middle where you just have individual water bottles either nested in a cage or some sort of carrier, so you can autoclave the whole thing and then introduce that into the isolator. I think that's probably one of the more handy ways. And then kind of at the bottom of the screen, a very small picture, unfortunately, is HydroPack, and something relatively new in the market in the last maybe 5 years. Yes?
So how large is the volume, and do they need special cages?
Actually, they use them here in this facility, and I don't believe it's a special cage. And it would be probably better to ask one of the folks here at Taconic as to how long that pack, that versus the traditional, like, 16-ounce bottle, what the difference would be. I don't really know that answer. Testing services. And so when you receive the isolator, years ago we used to actually ship the isolators. We used to sterilize them before we shipped them. And we would make that claim on our literature. And one of the things that I found is that really doesn't do much of a service for the customers, because how do you know from the point it leaves my facility to the point it gets into your facility that it's sterile? So it really doesn't do much of a service to say that it's sterilized. We clean them and we ship them, and it's really up to the customer to sterilize them. So here we're talking about germ-free work. So this is one of the most critical steps is setting up the isolator and then sterilizing it. And it's not enough just to take it on faith that it is sterile after you do that. No matter how, you could do it 2 times, 3 times, 4 times, and still miss something. So it's very important to do. I have a number of different things there, but really it's microbial testing. So you're going to swab the isolator and test the isolator to validate that it was in fact sterile. And then when we're talking about the health monitoring of animals, again, we're talking about germ-free animals, we're talking about valuable models. So the problem comes in, are you going to actually sacrifice any models, any animals out of that isolator to use? Probably not. So you're kind of limited to doing the swabbing of the isolator and then fecal pellets, and test some of the bedding. So, and the staff at Taconic will probably talk about that in a lot more detail later. Isolators. This is a slide. A researcher asked Phil Trexler, who was the founding father of isolation technology back in the 40s and 50s, asked if he could fit a particular project in an isolator. And Phil said no. And then he added, but I can wrap your project in plastic. And I kind of like that take-home message, and that's kind of what I've used to guide me, is that, rather than think about traditional fixed sizes, we try to customize it to exactly what the customer needs at their site. And those needs are very different from facility to facility. So it's very important in working with vendors to make sure that they have that capability to customize the product to fit your project-specific needs. So the first of those issues is the chamber size. And this is just a quick CAD rendering of a basic isolator. And in terms of cage capacity, whatever the capacity, the number of cages and number of animals that you target that you think you want to have in the isolator, you want to make sure that the chamber is large enough to, maybe 25 to 30% larger than that, so that you can introduce as many supplies as you possibly can on each pass. So you want to maximize that capacity and just load it up with supplies. Every time you open that door, bring in as much as you can. Exit, try to coordinate and limit your number of openings and closings, the port door or the port caps. So it's important to, so the first step in that is the chamber itself. And here we have some extremes. A very small isolator, which probably wouldn't be appropriate for germ-free work, and a very large isolator, which probably wouldn't be appropriate for germ-free work. But somewhere between there, you can kind of get the optimal size for what you need for your particular project. And then we get into port configuration. And there are 2 methods out there now. One is a door, simple door, which most of my products have a simple door. Or if you see on the side, on the left-hand side, there's an open 12-inch port. Doesn't have a cap on it, and this was just the initial setup here at Taconic. So we have the ability now to have not just, so it's not an either-or case with our isolators. You can actually have both a square door, and I'll explain why that's important. So there we go. There's 2 other views of ports. The round port evolved basically to be able to mate up a cylinder to an isolator. And the cylinder is a stainless steel device that's loaded with supplies to stock the isolator. That's one methodology of doing it. And it's one that was used in the very beginning. It's something that's still out there today, and I think there are people here today that are still using cylinders. And down in Germantown, they use cylinders extensively. So we have gone to more frequently the rectangular port, because we found a lot of people don't have the access to the large autoclaves. So the rectangular port, if you're using the gamma irradiated product that comes in a plastic bag and things that are vacuum packed, there's really no need to have the cylinder. So why live with the inconveniences of the caps and so forth? We can just have an easy open door. So this is the supply cylinder that I was referring to, and you can see he's stocking the cylinder, and prepackaged food and bedding goes into paper bags with the autoclave taped, and then stocked into the cylinder. And here we have another alternative that we developed. So the door is very convenient, But then what do you do when you want to introduce animals, and particularly with germ-free? There's only one thing that I recommend for transferring animals into an isolator, and that's the GermFree Shipper that Taconic has. There may be other ways of doing it, but if you really want it to be successful and limit the possibility of contamination, the GermFree Shipper is really the way to go. And so this is a way of, you could have a permanent devoted, 12-inch stub of pipe on the side there as a port, or in this case, you would just have this temporary thing. So when you do the transfer, you put this little device on. When you're finished, you can just take it off. And the next topic that I'm going to discuss is timeline planning. And a number of different topics there that we're going to cover: staff selection, discussing and writing SOPs, ordering equipment, ordering supplies, ordering animals. Staff selection. In terms of the people that should be doing the work, it really comes down to, and you can say it 3 times, and it maybe sounds silly or trite, but attention to detail, and attention to detail, the 3 most important things. So and the next, SOP writing, and that's, the people, if you're the investigator, you're the people that are doing the germ-free work, you're not going to be able to do everything. So you're going to have to delegate some of this to the lab animal people. And it's not that they're not competent, but this is not what they do every day. So I think that the linchpin that makes the whole project successful is to get everybody that's going to be involved throughout the project involved in day 1, sit down and do some pre-planning, write the SOPs, and do it all together, so that whoever is going to be involved in that process is involved from the very beginning and understands the complexity and the nuances of doing germ-free work. And so it goes right from the investigator to lab animal resources to the facility people. In some instances, there are even other groups that are going to be involved. So it's really important to get all the groups to the table, discuss it, and run through the whole project and understand that it is not just routine, business as usual. Equipment. In terms of the logistics, monitoring vendor lead times. It does no good to, we're talking about a living, breathing product, so you've got to dovetail, make sure that the isolators are there in time to receive the animals. Sounds basic, but I can tell you that building isolators is always a moving target. Times are slow. It's as little as 2 to 4 weeks, but lead times can get out there around 12 weeks. So it's just important to discuss with your vendor, make sure that they understand, what your timeline is, and be able to achieve those goals and get the isolators in plenty of time. Part of that, and why I say it's so important, particularly with the isolators, is that you still have to bring it in. You have to sterilize it. You have to validate that it's sterile, and these things take time. And there's no way that you should ever give it short shrift and just, bring the animals in before you actually know that isolator is sterile. Sounds basic, but I see it, people try to rush it all the time, and it's very rarely successful. Site-specific details, and probably should have put that first, and that's do a walkthrough. With the isolators in particular, it's a big piece of equipment. Make sure that it's going to fit where you want it to go. I know it sounds silly, but I've been in the business 16 years, and people go, the corridors are big enough, the room's big enough, there's no problem. Now, it's on the 3rd floor, there was an elevator involved, the elevator wasn't big enough. Now what do you do? I've actually had companies have to knock a hole in the wall and have a rigger bring the isolator in because they just ignored that thing. And, there's a silly little thing that I always say is that take a piece of cardboard, get the footprint of the isolator, and walk it through. And I don't know that there are that many of us old enough to remember Romper Room. They used to have the little paper car, and they used to walk around with the paper car. It's like cut the little paper car and walk around the facility and make sure it fits. And you can measure, and I don't know, somehow the devil's in the details. And just that one little turn or that one that one elevator, makes life really miserable. Yes.
Not just the isolator, but also whatever equipment you're going to be using.
Yeah.
If you're using cylinders, keep in mind that they have to be attached to the end. If you have to turn the isolator to make the cylinder connect, you need to be able to move your equipment around within the room. So just being able to fit is not out all the-
Absolutely, it's that kind of, yeah, absolutely have to map out that thing. And you know, from my point of view, I mean, I've put isolators everywhere, and literally when I say I've put them in a janitor's closet, broom closet, we actually put them in a broom closet. But you know, with this, if you're talking about cylinders, and you don't, you know, you really want to map it out and make sure you have plenty of room.
As well as, you know, other supplies, like you're going to keep
Absolutely, yeah.
support materials in the same area, and you're going to space for that, of course.
Absolutely.
Are there any special electrical requirements for the room as well? Does it really need to be formatted with outlets of a certain type? Or?
Like any other electrical device, you have kind of standard things nowadays. Is standard configuration. You shouldn't need extra outlets because at best there's a blower, and in some of our products we put a light. But that's it really is just a standard 110 outlet, 15 amp. Supplies again. Vendor lead time with the isolators, I already talked about that, 4 to 10 weeks. I've seen it creep up to as much as 14 weeks, unfortunately, in really peak times. And then there's the internal lead time. How long does it take to test to get the isolator in, to do the initial sterilization, to get all the supplies together, load it into the isolator, sterilize it, and then validate and test, do your microbial testing. So you just have to be very cognizant of those lead times. Animals, and here we have the GermFree Shipper that I referred to. And if it isn't possible to make the GermFree Shipper up to the isolator for some reason, then there's always the possibility of doing it in a clean hood, transferring the animals to a Nalgene, a wide-mouth Nalgene container, and transferring them individually in those, and transfer them into the port. It would be the less desirable way. The only way I would recommend is the GermFree Shipper. It's an ideal little device, and it's been around for, God, I'm going to guess 40 years. And I've been asked, by different folks, can you do something to make it better? Yeah, we probably could, but it's a pretty good little device. So, just in finishing up, timing is everything. With the timeline planning, again, I've kind of hit it a number of times, but to just make sure that everything dovetails, to make sure that you get the isolators in plenty of time, the supplies in plenty of time, train the staff. There's something that I kind of left out. Training, not just writing the SOPs, but then training the people on how to if they haven't used isolators before, how to use the isolators, and again, to go over the importance and the complexity of germ-free work and how important it is for everything to dovetail. And that is all I have.